Example 3 says a 43.9 gram sample of iron has a specific heat capacity of 0.45 joules per gram degree Celsius. What was the final temperature of the sample if the heat absorbed was 82.3 joules and the initial temperature was 47.3 degrees Celsius? So let's set up our variables, Q, M, C, and then delta T is my change in temperature. 43.9 grams is my mass. 0.45 joules per gram degree Celsius is my specific heat. And 82.3 joules was my energy, so 82.3 joules. And my initial temperature was 47.3. So when I look at change in temperature, delta T is temperature final minus temperature initial. I am trying to solve for the final temperature. My initial temperature was 47.3. So temperature final, that's the variable that I'm trying to solve for. So let's plug in our numbers into our formula. Q equals MC delta T. $82.3 equals 43.9 times 0.45 times temperature final minus 47.3. And at this point, we're just rearranging our numbers to try to get that temperature by itself. So how you do it is up to you. I like to go ahead and combine the terms that I can. So 43.9 times 0.45. And I get 19.76 times TF minus 47.3. That equals 82.3. You have two options here. The first option you have at this point is to distribute 19.76 times T and then 19.76 times the 47.3. I personally prefer to divide both sides by the 19.76. And then solve for temperature. So 82.3 divided by the 19.76. I get 4.17 equals final temperature minus 47.3. And then at this point, to get rid of the 47.3, I would add that to both sides. And what I find for my final answer, I have a final temperature of 51.5 degrees Celsius. And you can stop and ask yourself, does 51 degrees make sense? Well, the question said heat was absorbed, so we know that we should see a temperature increase. 51 is greater than 47, so this seems like a pretty reasonable answer.